Okay, we're back into our chapter. So we are in section 10.4. So this is the chain rule. So sometimes what happens is we come across something that we can't simplify easily, and we still have to find the derivative. So if I give you this function, x cubed plus 3, all raised to the 5th power, I could say, okay, just take x cubed plus 3, multiply it by x cubed plus 3, get that answer, multiply it by x cubed plus 3, get that answer, multiply it by x cubed plus 3, get that answer, and multiply it by x cubed plus 3. It's a long process, and I don't want to burden you with that, and I wished I could tell you that I came up with this, and I didn't. But the chain rule is actually a very, very powerful tool. Okay, so we use the we use the chain rule when we have a function embedded in another function. So if you look at this, we have our inside function, we're going to call it g of x, is x cubed plus 3. Okay, that's our inside function. Our outside function, we're going to call f of x, and it is a big something, we're going to call it big giant x, raised to the 5th power. Okay? So we have two things going on here. We have the inside function, x cubed plus 3, and we have the outside function, something raised to the 5th power. So what the chain rule does is it allows us to peel off the outside and then work on the inside. So think of it like a banana. When you eat a banana, you can't just eat the yellow skin, everything. You have to peel off the outside of that banana to get to the inside so that you can go ahead and eat it or work with it, okay? So that's what you're doing. That's the concept. We're going to peel off the outside, and then we can work with the inside, okay? That's called the chain rule. We're unlinking the chains that are connecting these two functions together. Okay, so when I say peel off the outside, what I mean is we're going to look at this whole inside function as one big giant blob. Okay, it's one function, and we're gonna keep it as the one function. So if I were to ask you to do x to the 5th power, and I said, okay, what is the derivative of that? Well, you would, if I asked you to find the derivative of this, you would peel the 5 to the front, and then you would subtract 1. Okay? Pretty easy. Well, if you think of this x as the big blob, now you have something to work with. So we are going to peel the 5 off. So our first derivative, the 5 comes to the front, so it's just the power rule. 5 comes to the front of the x cubed plus 3, that's that big blob that we've been working with. Okay, it's 1 unit. And then we are going to subtract 1. So 5 minus 1 is 4. Okay, so you just found the derivative of the outside. Okay, you peeled off the outside, and you found the derivative of the outside. All right? That's this part. That's f prime of the function. Okay? Now we have peeled this off. Now we can work with the inside. And that's what this says. Once you peel off the outside, now you get the derivative of the inside. So we look at just the derivative of the inside. The derivative inside is I bring my 3 to the front, and then I subtract 1. This 3 just goes to 0, and we have the derivative of the outside times the derivative of the inside. You see it? Derivative of the outside times derivative of the inside. Now I can clean it up. So what I can do is I can take these two pieces, the 5 and the 3x, and I can multiply them. So I get the first derivative is 15x squared times x cubed plus 3 to the 4th power. Now, why can't I multiply this x cubed plus 3 to the 4th power? You could, but it's going to be a long process, so we're just going to keep it simplified. The reason that I can multiply the 5 times the 3x squared is this is all multiplication. So if you think about the rules of multiplication, if I had 2 times 3 times 5, that's 30. If I rearrange them and I do 2 times 5 times 3, still 30. So you're going to get the same answer no matter which order you multiply it. Well, since this has the 4th on the outside, I don't want to mess with that. So all I'm going to do is multiply those two outside pieces. 3 times x squared is 15x squared. And that's it. That's the chain rule. Let me do a couple more. It takes a little bit just to kind of figure out what you're doing. Where people make their mistake is they forget to take the derivative of the inside. They get the derivative of the outside, but then they forget to multiply by the derivative of the inside. So let's try another one. How about f of x equals negative 3x to the 5th plus 1, all raised to the 3rd power. So again, you could go through and multiply negative 3x to the 5th plus 1 times negative 3x to the 5th plus 1, get that answer, and then multiply through it again. Way too long of a process. What we want to do is use the chain rule. How do you know when to use the chain rule? You know because there's an exponent bigger than 2 on the outside. Okay? Now, let me put it this way. It's an exponent other than 1 or 2 on the outside. Okay? And that will come into play. I'll do one in a minute. All right, so here we go. Just to identify, my inside function is negative 3x to the 5th plus 1. My outside function is something to the 3rd power. Okay? So we have two functions going on, inside and outside. So to get derivative, I want to get the derivative of the outside. So I'm going to peel the 3 to the front, rewrite the inside one, and subtract 1. Okay? I just peeled off the outside. I found the derivative of the outside. Now I need to find the derivative of the inside. So the inside is negative 3x to the 5th plus 1. So I drop my 5 to the front, and I get negative 15x. I subtract 1 to the 4th power. The 1 goes to 0, and there I have it. Now I'm just going to simplify it. My first derivative, 3 times negative 15 is negative 45x to the 4th times negative 3x to the 5th plus 1 squared. And I'm done. That's it. That's the chain rule. Let's try one more. Remember I mentioned that the exponent can be something other than a whole number. So if we had f of x equals the 4th root of negative 3x to the 4th minus 2. Okay? So again, the first thing I'm going to do whenever I see a radical is I'm going to rewrite it. So this is negative 3x to the 4th minus 2 raised to the 1/4 power. The index is my denominator. The exponent on the whole thing was a 1. That's my numerator. Okay, now you see it's not a 1 or 2, it's a fraction, but that's okay because we're going to peel this off. So the inside function is negative 3x to the 4th minus 2. The outside function is something to the 1/4 power. Okay, so I'm going to find the derivative. I'm going to peel off, so 1/4 goes to the front. I rewrite my inside function. And then I'm going to subtract 1. So I end up with negative 3/4. So now that is my outside function, the derivative of the outside. Okay, and now I'm going to multiply by the derivative of the inside. So 4 times negative 3 is negative 12x minus 1, so 3. Okay, so now I'm going to multiply 1/4 times negative 12. So watch. 1/4 times negative 12 over 1, I can cross cancel. So my first derivative is negative 3x to the 3rd times negative 3x to the 4th minus 2, all raised to the negative 3/4. If I want to rearrange this, this negative means this is going to be on the bottom. So I have negative 3x to the third over the fourth root of negative 3x to the fourth minus 2, all raised to the third power. So again, if MyMathLab asks you just to find the answer, that works. If it says write it in radical and positive exponents, then you'll have to be able to write it that way. That's the chain rule.